I'm Anil Kumar, and in this video I'll discuss unit circle. It is a very important concept which we use in trigonometry to read the values of trigonometric ratios. So here we have a circle whose radius is 1 unit. That is to say, a point here on the x-axis, you can say, will be what? Will be x value of 1 and y value of 0. A point on this side will be 0 for x and 1. On this side, it will be -1 and 0. And here, a point can be defined as 0, -1, correct? So these are simple points which we could definitely read when the radius of a circle is 1. Now, how do we read a point which is on the circle but somewhere else in between? That's a big thing to understand, and this is what we are going to understand in this particular video. Now, let's get to some basics before we get into unit circle and fill it with so many values. That is where students get confused. So what I'll do here is, let's take a point P, and at this point P, I'll drop a perpendicular. So let me call this point as point P, whose coordinates are A and B, right? So A is the x value, in general B y value. And let us say this angle here is angle theta. Now in that case, if I have radius of 1 unit, this radius is going to be always positive 1 unit. In that case, what is A equals to? Now A is the adjacent side, right? So A is this side and B is the opposite side. So you can clearly see that cos theta is basically equals to A over 1, adjacent over hypotenuse, right? A over 1, which implies that A is equals to cos theta. What is sine theta? Sine theta will be equals to opposite side over hypotenuse, right? So it is B over 1, since 1 is the radius of our unit circle. So we see that B is equals to sine theta. Now that clearly indicates that I could write a point P for a unit circle as cos theta sine theta. So what we have done with this simple exercise, that we have converted a linear xy real values in terms of trigonometric ratios sine theta and cosine theta. Do you see the beauty of it? Correct? So this is one part. So any point on this circle will actually give you directly the values of sine and cosine. And of course, tan is the ratio of sine and cosine. So B over A will be tan theta, right? So we could write tan theta as equals to B over A. Perfect. So that gives you the primary trigonometric ratios. So this is one concept which you need to understand. Now, so let me write down SOHCAHTOA over here, which helps you to remember what is sine, cosine, and tan, right? So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent side. Perfect. Now, as we move from quadrant 1 to 2 to 3 to 4, what happens to sine and cosine values? Let's look into that also. Let's say this is our quadrant 1, right? This is quadrant 2. Here we have quadrant 3, and then we have quadrant 4 here. So as we move from one quadrant to the other, let me just use this space to work that out. We know all are positive in quadrant 1, correct? All are positive in quadrant 1. Sine is positive in 2, tan in 3, and cosine. You could remember this either way. All students take calculus, for example, or whatever rule you have in your mind. But ultimately, you know, here all are positive. In this quadrant, sine is positive. Well, it makes sense because y values, which corresponds to B, are positive in quadrant 2. Correct? In quadrant 3, both are negative, so the ratio B over A is positive, And in quadrant 4, A is positive, right? A is positive. So cosine is positive. It makes sense. So when you look at this unit circle, you see that the cost rule is very well reflected there, right? Okay. Now one more thing is to relate position with 2 pi. Okay. So what is the circumference? Circumference of a circle, as you know, is 2 pi r. 2 pi r. In our case, r is 1 because we are talking about unit circle, correct? Unit circle. And therefore, the circumference for us is 2 pi. It really means that if I'm trying to move around in one full circle, I go around 2 pi. Correct? 2 pi is the distance traveled along this circle. Now, if you talk about angles, one full circle 2 pi, that is angle in radians, right? So we see that this is also angle in radians. And therefore remember, the concept is based on angles in radians. You can always, convert radians to degrees and then use the same chart for degrees also, but it comes from our concepts in radians. So as we move on to calculus, for example, all the angles will be measured in radians. Okay. Now let's assume that we are at this point and we move horizontally, right? With time t, where t belongs to real numbers. Okay. And we consider this length as also equal to, let's say, some other length s. I'm using s because I want to use this s moving along the path of this circle. Okay. So at time t, let us say we move this much of distance, and this s moves a distance shown here from this position to point P. Then along the arc of a unit circle, s will be equal to r theta, right? S will be equal to r theta. Since r is 1, s is equals to theta. Do you see that? So the arc length traveled is a reflection of the angle itself. The arc length traveled is a reflection of the angle itself. Do you see that? S is equals to theta. But since s is same as t, where t belongs to real numbers, we could represent any movement along this axis with s. As soon as t is more than 2 pi, then it will again start from here, right? So it repeats. Do you see that? So what we have done here is that t belongs to real numbers has been translated to a circular motion. Do you see that? Where the arc length represents the linear distance traveled, right? And this arc length is a reflection of angle in radius, theta. Okay. And what we're trying to figure out here are trigonometric ratios in a circular motion. We also call them, therefore, as a circular functions. Correct? And their value, or the time period for sine and cosine, is 2 pi, right? After every 2 pi, they repeat. Correct? So what we have learned in this part of the video is kind of connected with some basic concepts and a unit circle. And now we will fill up this unit circle with values so that you could directly read sine and cosine values from the circle itself. Now, let us try to place values on our unit circle so that we could read trigonometric ratios directly. Things which you need to know is acronym for learning what sine, cosine is. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent, correct? Another thing which you need to know is in these four quadrants, what is positive where, right? All are positive in quadrant 1, sine in 2, tan in 3, and cosine in quadrant 4. So we're talking about these four quadrants, which are 1, 2, 3, and 4, correct? Now, what we also learned here is that any point on this circle, let's say we have a point P, which has A as the along the x and B along the y, then this could be written as P of cos theta sine theta. Is it okay? So directly the xy values correspond to cosine and sine. Now the thing is, how do we write these or remember these values? Okay, so we'll begin with our special triangles, which are let's say 30, 60, 90. Let me first make 30 degrees 30, 60, 90 triangle, where this angle here is pi by 3, here it is pi by 6. So I prefer to make both in one. So normally we may write values like equilateral triangle with 2 units, half is 1, and this is square root of 3. Since we have a case where we want radius to be 1, I will redraw this and divide all by 2. So the same triangle, if I divide by 2, I get this as 1 length, and this becomes half, and that becomes square root 3 over 2. I hope that makes sense, correct? This is for the same triangle, which is 30, 60, 90 degrees, or in radians, pi by 3, pi by 6, and 0. You could also write this as 30 degrees, 60 degrees, 90 degrees triangle. Is it okay? So either way, both are same. So pi by 6 is 30 degrees, pi by 3 is 60 degrees, and pi by 2 is 90 degrees. So these dotted lines which I have drawn, they actually corresponds to our special angles. So the first one here drawn is for 30 degrees or pi by 6, right? So this is for 30 degrees or pi by 6. So let me write this angle as, let me write here, it is 30 degrees or you could say pi by 6. Does it make sense to you? Okay. The coordinates of point represent sine and cosine values. So for pi by 6, what is cos pi by 6? You have to look from this side, adjacent is square root 3, hypotenuse is 2. But what we can do is, we can read this value directly from our triangle whose hypotenuse is 1, right? So that becomes the value. Is it okay? So we get the point as, let me now write down the point as square root 3 over 2, and that is opposite to pi by 6, the value of half, correct? So sine is opposite, adjacent is cosine. So if you're looking from this angle, pi by 6, adjacent is square root 3 over 2. Does it make sense to you? Okay, now let's get back to this point. Now here also, the related acute angle is 30 degrees, correct? However, what you notice here is that the x value should be negative, correct? So we write minus square root 3 over 2 for the x value, y value is positive, there you go. Is it okay? Now this point here also has a related acute angle of 30 degrees, right? So we are talking about 30 degrees angles now, which I'm showing here. Is it okay? In 4 different quadrants. So here you see both are negative. So we'll write this as minus square root 3 over 2 and minus half. Does it make sense to you? Here the x value is positive. So we have square root 3 over 2. The cosine is positive, right? Cos rules, cosine is positive. And then the sine value is 1 over 2. So we have got 4 of the points. using one of the special triangles. Does it make sense to you? Now let's look into the second triangle, which is pi by 4. Okay, so here we have the angle as pi by 4, or you could say 45 degrees. Either way, is pi by 4 in radians, 45 degrees in degrees. So some of us draw this as 1 square root 2. Now the same triangle is also seen in different parts. We'll divide by square root 2 now. So if I divide by square root 2, I get 1 over square root 2, 1 over square root 2, and I get a unit hypotenuse, which we are interested in. However, we don't want square root 2 in the denominator. So what should I do? Since we don't want that, we'll normalize it, right? So I'm drawing the third one by normalizing. Normalizing really means we'll multiply and divide by square root 2, all the values. Is it okay? Okay. So that gives you the final pi by 4 triangle, which is 1. And this becomes square root 2 over 2, right? Square root 2 over 2. Does it make sense to you? That is how you get this value. Now, these are these values for us. Midway, correct? Now, you can actually pause the video, place these values. In quadrant 1, this value will always be, both x and y values are same. Both sine and cosine values are same, since these two legs are same, correct? And they are square root 2 over 2, square root 2 over 2. In quadrant 1, both are positive. In quadrant 2, sine is positive, so we'll have negative square root 2 over 2 for A, and for B it remains as positive. Now in this case, both are negative, so we have square root 2 over 2 and square root 2 over 2 negative. Both are negative. Here the x value is positive, so we have square root 2 over 2, but negative square root 2 over 2 for sine. Do you see that? So we could read this very easily, correct? Now the third point which we're talking about here corresponds to 60 degrees, or you can say pi by 3, correct? So we can again go back to our 30-60 triangle and read the values. Cos value, adjacent side is now this one, right? This is A and this is B for us. So we could write this value as half and square root 3 over 2. So half and square root 3 over 2. Do you get it? So this is corresponding to that point. Now, in other quadrants, the acute angle is this one, correct? 60 degrees. So these points will be, again, half will be negative now. The cosine value is negative here, but sine value is positive. 60 degrees. So when we say 60 degrees, we are talking about pi by 6 acute angle. Do you see that? We are talking about this angle. We are talking about this angle. Do you see that? This related acute angle alpha 60 degrees. Perfect. Okay. So this value here, both will be negative. So it is adjacent side of half and square root 3 over 2. And in this quadrant, x value is going to be positive. Both negative here. X value is positive, however, negative value for sine, which is square root 3 over 2. Sine corresponds to y values. Perfect. These points, they are the intercepts of unit circle 1, and I could easily write them as, this is 1, 0, correct? Here we have 0, 1. Here we have minus 1, 0. And here we have, let me write here, 0 and minus 1. So, from the curve, sine and cosine also, these everything match. Do you see that? So that becomes your unit circle, correct? Now, you can actually fill in with the angles. We did write some. So if you want to write in degrees, that could be the one. And if you write it in radians, it is pi by 2, this side, correct? And accordingly, you can move along So when we talk about 60 degrees, for example, this is 1 pi by 3. So in radians, this becomes 2 pi by 3. Do you see that? 2 pi by 3. Here, it is 3 pi by 3. And then 4 pi by 3. This is 4 pi by 3. 5 pi by 3 will be here, correct? For 60 degrees, there we are, 5 pi by 3. And 6 pi by 3 is 2 pi, correct? So we have written this. As far as pi by 6 is concerned, so we already have 1 pi by 6. This is 2 pi by 6, 3 pi by 6, 4 pi by 6, 5 pi by 6, correct? So this angle is 5 pi by 6, 6 pi by 6, 7 pi by 6, correct? So we have 7 pi by 6 here, and this will be 11 pi by 6. So easy, correct? Pi by 2, this is pi, 3 pi by 2, and that could be 0 or 2 pi. So in radians, we have filled it up. You can accordingly convert degrees to, radians to degrees and write it down. That's so simple. Another graph which you may like to use and remember is sine and cosine functions. So which I'll show here, sine and cosine functions. Sine function will be like this, one sine wave, and the cosine function will be like this, one wave, right? So that is how their values change. So if you see for sine, let's say sine theta, this is for cos theta. To start with, y value is 0, right? And then it becomes 1 here, and then again it becomes 0. And as we go here, we get -1, and as the cycle completes, it becomes 0. As far as cosine value is concerned, the x values or a values starts with 1, correct? Goes to 0, then to -1, correct? 0, and then to +1, correct? So that is how you could relate with sine and cosine curve also as we move along this circular path. So this particular shot at the video is a very important shot. It gives you a lot of information about, just from looking at it, how to find trigonometric ratios. And one thing which I'll write here, tan could be b over a, right? So what we have here is that sine theta is the a value, cos theta, b value, b. Cos theta is the a value, and tan theta is ratio of sine and cosine, which is b over a. So that really completes it. So I hope you understand the unit circle. If you have any questions, feel free to post them. If you like, that would be great. Share my videos and subscribe to them. Thank you, and all the best.